For magnetic force, positive charge or current, fingers or field, force. Here we go. Positive charge, velocity that way. Field is that way, force is up. Negative charge, velocity that way. Field is that way. Force is that way, because it's negative. Current, that way. Field that way, force is to the left. Current that way. Field that way, force is down and right. Negative charge, velocity that way. Field is that way. It's a negative, so up. Positive charge going that way. Field, force. Okay, second round. Magnetic field pointing to the right now. Velocity 0, force is 0. Velocity lined up with the B field. Force is 0. Force is 0. Force is 0. Velocity that way. Field is that way. Force is out of the board. Positive that way. Field is that way. Here's the angle theta. Force. Current that way. Field is that way. There's your angle. Force is out. Negative going that way. Field is that way. Positive would be in, so it's out. Velocity that way. Field is that way. Force on a positive would be that way, so it's out. Current going that way. Field is that way. Force is in. Charge flowing that way. Force ends up being upward, so the field must be in. Here, the velocity is that way. The force ends up that way, so the field must be out. Here we have the velocity that way. The force ends up that way, but that would be if it was a positive, so the field must be in. If the velocity is inward, and we know the force is that way, but it's a negative, so magnetic field must be pointed downward. Finally, if we don't know the velocity, the magnetic field is this way, the force is up, so the flow of positive would be out, so the flow of negative would be in. But that's not the whole story, because it could also have a component along the field making no force. So inward definitely, sideways maybe.